we're going to learn about the scheduling algorithms. In the last video, we have discussed about the CPU scheduling. Today, we are going to start the scheduling algorithms. First of all, these scheduling algorithms are classified into two types. One is preemptive and the other one is non-preemptive. As we have already discussed that in primitive algorithms, the process can be preempted in between. The process which is allocated with the CPU can be deallocated forcefully at any point of time. Whereas in the non-preemptive algorithms, the process once the process is allocated with the CPU, it will only preempt until it completes its execution. There are mainly two types of non-preemptive algorithms. First one is FCFS, and the second one is SJF, shortest job first. In primitive algorithms, there are mainly three types of algorithms. First one is shortest remaining time. Shortest remaining time first. And the other one is priority scheduling. And the last one is round robin. So, there. Let's start the first algorithm, FCFS. FCFS stands for first come, first serve. As the name suggests, in this algorithm, the process whose arrival time is less than it will be served. The process with least arrival time in the ready queue will be served first. And if two processes will have the same arrival time, then the process with least process ID will be considered first. And there are some limitations for these algorithms, like it causes starvation if a process with a high burst time will arrive first and the remaining Processes with least burst time are waiting for their time until the longest process is completes its execution, which causes starvation for the small processes waiting in the ready queue. Let's see the steps to solve a FCFS algorithm. First of all, we have to sort the processes based on their arrival time. Step 2, the completion time of the first process after sorting will be equal to the arrival time of that process and equal to the sum of arrival time of that process and the burst time. Step 3, calculate the calculate the completion time of the remaining process. Completion time of the remaining by adding the burst time to the completion time of the previous process. Of the previous one. But if the arrival time of the current process is more than the completion time of the above process, then use the step 2, like it is the sum of the, in that case it is the sum of the arrival time of that process and its burst time. Let's see this problem and solve this using FCFS and calculate the CPU idleness. First of all, we use a Gantt chart. Gantt chart is nothing but a permutation of the processes. It represents the time period of each process burst time along with CPU idleness. CPU idle. Like it is represented with an rectangular boxes. Let's draw the Gantt chart for the given problem with FCFS. As I told you that to solve an FCFS problem, first you have to sort the given processes based on their arrival times. So let's solve these processes. Let's extend this tabular form and write the okay, let's draw another one. Here we go. Let's draw the arrow vector. There are totally five processes. Let's not move it. Let's write this. The first process will be the second one with arrival time 3, and then its burst time is 2. This second one will be the first process with arrival time 5 with burst time 1. The third one will be the process with process ID 3 whose arrival time is 8 and burst time is 4. And the fourth one is the process with process ID 5, arrival time 9, and the burst time is 3. And the fifth one is the process with process ID 4, arrival time is 12, and then burst time is 7. So, I'll write, so not a problem. Now, once we sorted the processes, the completion time and we also have the waiting time and turnaround time. As I told you that the completion time of the first process is just the sum of the arrival time and its burst time. Here in this case, sum of 3 plus 2 is 5. Waiting time of the first process will be 0 and the turnaround time will also be the 0. Second one, the completion time of the second process will be the sum of the burst time of that process, which is 1 plus the completion time of the above process, which is 6. Waiting time is nothing but the, let's draw the Gantt chart, then it will be easier for us to visualize. Here, if we see, the first process was arrived at time t equal to 3. It means from 0 to time t equal to 3, the CPU was idle and then it executed the process 2 for 2 seconds and then now the time is equal to 5. It started the execution at 3 Then it executed the process number 1 for 1 second, making the time t equal to 6. And then after, the CPU was idle until a process 3 arrived at 8 second. So the CPU was idle for 2 seconds. And then next, at t equal to 8, a process number 3 has arrived with burst time of 4. So t equal to 4 here. Let t equal to 12. 8 plus 4 is 12. 12. Then after at time t equal to 12, a process with a process ID 5 has arrived already before the completion of this process, and the burst time of that process is 3. So the current time is 15. Let me draw a line at t equal to 15. Then after execution the process number 5, process number 4 will be executed with a burst time of 7. So the total time will be 22. This is going to be the entire CAN chart where the shaded area represents the idleness of the CPU. It means the CPU was idle at this time period. So let's solve the completion time, waiting time, and turnaround time of each process. Let me give the process. This is process 2, and then the second one is the process 1. Then after the process 3, then after process 5, and then process 4 has been executed. Let's remove all of this and write the completion time, turnaround time of each process over here. Okay, let me change the headings. Okay, no problem. Let's write in this way. CT indicates the completion time and TAT indicates the WT indicates the waiting time and TAT indicates the turnaround time. Turnaround time is the time period of the process that the time period that is being spent by the process in the ready queue. So for the process number 1, let's also make another column. One tab. PID indicates the process ID, CT for completion time, WT for waiting time, and TAT for the turnaround time. Process for the process one, the completion time will be at t is equal to 6 and the waiting time is 0 and the turnaround time is, oh my god, waiting time is 0 and turnaround time is 2 because it arrived at 5 and completed its execution at t is equal to 6, so the turnaround time is 1. The next one is the process number 2. For the process number 2, the completion time is t equal to 5 and waiting time is also 0 and the turnaround time is equal to its burst time, that is 2. The next one is process 3. For the process 3, it has arrived at t equal to 8 and the completion time is 12, waiting time is 0 and the turnaround time is equal to its burst time, that is t equal to. For the process number 4, the completion time is 22 and the waiting time, process number 4 has arrived at t equal to 12 but it started executing at t equal to 15. It means it has waited for a time period of 3 seconds and the turnaround time is 10 seconds. And the final one is process number 5. It completed at time t equal to 15 and it has arrived at time equal to 9 and it waited till time equal to 12. It means its waiting time is going to be 3 and the turnaround time is nothing but a waiting time plus burst time, which is 6. So in this way, we're going to solve this problem. Let's calculate the CPU idleness. CPU idleness, the formula for the CPU idleness is total time, total CPU time divided by schedule length. Schedule length is nothing but the time period in which the first process has started executing and the arrival time of the first process minus the completion time of the last process. Schedule length. Schedule length into 100. Let's calculate the value of this. Here we can see that the CPU, the total idle time of the CPU is 3 plus 2 divided by this total schedule length is 22 minus 3. It means 19 into 100. Let's calculate the value of fiber in is 1 by 2 and it's okay, so that without calculator it's here we have to write 19 5 by 19 into 100. 5 divided by 19 into 100, which is equal to 26.3. 26.3. And similarly, we can also calculate the CPU efficiency, which is nothing but 100 minus CPU idleness, which is equal to 100 minus 26.3, which is nearly equal to 73.7. So this is all about FCFS. I hope you like this algorithm. Thank you for watching.